Hi there, in this video I'm going to do a past exam question on integration. So let's take a look at the question. So question number 2, use the substitution u equals 2 to the power of x to find the exact value of the definite integral between limits 0 and 1 of 2 to the power of x over 2 to the power of x plus 1 squared with respect to x. So let's see how this can be done. Let's go back to the paper and pen. Now here's the integral that we need to calculate using this substitution u equals 2 to the power of x. Now if you're unaware about the method of substitution, I have created videos on substitution and I'll provide links to those videos in the description below. Let's go through the method of substitution with this example though. So u, our substitution, is 2 to the power of x. We need to calculate du over dx. So that is what we need. We need the derivative in order to replace the dx term by a du term. So that is one of the ideas of substitution. Now to differentiate 2 to the power of x, there is a result. If y equals a to the power of x, dy over dx will be a to the power of x multiplied by ln a. So this is the result that we need to use in order to help us with the substitution. So applying this result here, if u equals 2 to the power of x, according to this result over here, I'll get 2 to the power of x times ln 2. So that is how you would handle the derivative. Now, regard du over dx as a fraction, so technically it's a function, but if you regard it as a fraction, I can bring the dx to the right to give us du, which is 2 to the x ln 2. So if you regard du over dx as a fraction, you can bring the dx here to give us du, which is 2 to the power of x ln 2 dx. So let's stop and think over here. So let's think about what we're going to do next. Now, we need to replace 2 to the power of x ln 2 dx somehow by du. Looking at our integral, we only have 2 to the power of x dx. We need an ln 2 on top ideally in order to replace the entire term by a du term. Now, I can introduce an ln 2 term over here by multiplying the numerator and denominator of this integral by ln 2. So let's do that. If I continue, I can write this integral between the limits 0 and 1. If I multiply the top and the bottom by ln 2, I'll get 2 to the power of x ln 2 divided by, I also need to multiply the denominator by ln 2 as well to give me ln 2 into the 2 to the power of x plus 1 squared. Now, don't only multiply the numerator, you need to multiply the denominator as well. And as you can see, I haven't altered the structure of this integral as the two ln terms will cancel. Now, why did I do this again? I did this because I can then replace the 2 to the power of x ln 2 dx, so all of this I can replace by du. So I can replace all of this by du when applying substitution. 2 to the power of x is u, so I'll replace the 2 to the x by u to give me a u plus 1 squared. ln 2 is a constant. However, we have limits, and when it comes to substitution with limits, you need to calculate the new limits. So these are the limits involving x. We need to calculate the new limits in terms of the u variable. So let me show you how that is done. Let me show you how to work out the new lower limit. So to work out the new lower limit, take the old one relating to x, which is x is equal to 0, and put that into your substitution for u. So u will be 2 to the power, x replaced by 0, 2 to the power 0 is 1. So 1 being the new lower limit. let's do the same. Let's work out the new upper limit. So if I put the old upper limit, which is x is equal to 1, into the substitution, we'll have u, which is 2 to the power of 1 for x. 2 to the power of 1 is 2. So 2 being the new upper limit. Now we're ready to rewrite this integral using substitution. So by substitution, let's rewrite this integral. So integration sign. Now, as we discussed, 2 to the power of x ln 2 dx, we'll replace that by du. So let's replace that by du. And as we replace terms, let's check them. So this entire term we've replaced. So we're ending up with a 1 over then. ln 2, that's a constant. Let's keep that there. 2 to the power of x. So 2 to the power of x is replaced by u. So I'm going to have in a bracket u plus 1 squared. So I have u plus 1 squared, don't forget. And as for the limits, the new limits correspond to 1 and 2. 1 is the new lower, 2 is the new upper. So let's include those. So 1 new lower, 2 new upper. So I can rewrite this as, I like to take the constant out of the integral, so you can only take constants out of the integral. If I take 1 over ln 2, so 1 divided by ln 2 out of the integral, we're going to be left with the integration of between limits 1 and 2. Now u plus 1 to the power of 2, I could write that as u plus 1 to the minus 2. And why did I rewrite it like this? Because there is a result, so there's a quick result for when you integrate ax plus b to the power of n. Now, if you're unaware of this result, I have created a video on this result and how it's applied, and I'll provide a link to the video in the description below. But let me talk to you about this formula. Now, the formula says we add 1 to the power. So when I add 1 to the power, I'm going to have n plus 1. We divide by that resulting power. Resulting power is n plus 1. We also divide by the coefficient of x. Coefficient of x is a. So a is the coefficient of x. And let's just add c for completeness. So remember the result. Add 1 to the power, divide by the resulting power, divide by the coefficient of x. So we can only do this if the term here is of the form ax plus b, i.e. a linear. So let's apply this result here to this integral. So I have 1 over ln 2 outside, a constant. And when I integrate, let's integrate u plus 1 to the minus 2. Add 1 to the power, remember. So minus 2 plus 1 is minus 1. Divide by that resulting power, which is minus 1. The coefficient of u is 1, so let's divide by 1. And let's close that bracket, and the limits, remember, are 2 and 1. Now, if we calculate the solution to this, we've calculated the solution to the original integral. So let's work out the solution to this. So upon replacement of the upper limit, which is 2, we're going to have, so let me continue here, 1 over ln 2. And if we put the upper limit, which is 2, I'll have 2 plus 1 to the minus 1 over minus 1. So I'm going to write that minus here. So 2 plus 1 to the minus 1. That is what you should have upon replacement of the upper limit, which is 2. Minus, and let's replace the lower limit 1. So minus 1 over ln 2. So minus 1 over ln 2. When I've replaced the lower limit 1, I'll get minus 1 plus 1 to the minus 1. So that is what you should have upon replacement of limits. Now when I simplify, I'll have 1 plus ln2 from here, and in a bracket we have a minus, so let me retain the minus. 2 plus 1 to the power minus 1 is the same as 1 over 3. Don't forget to keep the minus in front. And from the second term, I've got minus 1 over ln2, opening another bracket. Let me retain that minus. And 1 plus 1 to the minus 1 is the same as 1 over 2. So what I'm going to do now is, if I factorise, if I take a common factor of ln2, or 1 over ln2 rather, so let's factorise by taking a common factor of 1 over ln2, I'm left with minus 1 over 3, minus into minus is a plus 1 over 2, and I can simplify this bracket, so minus 1 over 3 plus a half is 1 over 6 times 1 over ln2 outside is 1 over 6 ln2. So that should be the solution to this integral using substitution. So that ends this question, and that sadly also ends this video. So I hope you found this video helpful. I hope you enjoyed the video. Again, if you're unaware of substitution, I will provide links to the videos that I've done on substitution, and the links will be provided in the description below. However, I hope you enjoyed this video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related exercises, and I hope to see you again. Thank you.